So we ended your homework with inverses. We're starting today's lesson with inverses. All right, and the inverse of an exponential function, well, an inverse of an exponential is a logarithmic. All right, now we need logs because we have to have a way to solve things we don't know, like 2 to the x equals 6. I don't know what power to raise 2 to get 6. I know 2 squared is 4. And I know 2 to the third is 8.
So 2 and a half.
Yeah.
No, try it. Not quite right. Yeah. So we had to have a way to solve for those things. And it is a logarithm. Alright, so what you need to write is in the box. And then the examples that we're going to do together are below. So today we're learning about logarithms. They just help us solve these problems that we don't know how to do yet. Now, exponential form. This is what we're already accustomed to. We have a base raised to an exponent equaling an answer. B to the x equals a. That's exponential form. Log form looks different, but it's necessary and helpful. So I'm going to give you just a moment to take these notes, and then we'll try the problems.
Miss Willie, when I went in the cruise ship, I saw something that looked like that.
Okay, never mind. I can't pause it, so whoever's watching this video now, just fast forward till something starts happening.
Oh, that's awesome.
Better get your voice too.
I like that.
I'm gonna start calling Miss Willie.
We lost you. That's right. You lost? Alex, you lost?
Those of you that would like to take notes, now is your moment.
I'm trying my best.
I'm good. Let's do this video.
Lock.
Miss Willie, do you have any
Okay, my thought on the homework for this week is that I will create a homework category where I actually enter the grade you made. But this week I'm not going to let it count towards your average. But I need you to see how you're doing on homework legitimately. Like, before we take a test or quiz, so you will know how to expect to do on a test or quiz.
And then we'll start doing actual.
What?
So we'll practice this week.
Couldn't you just grade our sheet homework accuracy about this semester? Probably like this week.
It's actually not human.
What about it?
Oh, yeah, because the computer does it for you.
Yeah.
They,
For me,
they never
physically
said
grade
they weren't.
110 pages.
That's true. I didn't think about that aspect.
Yeah.
Remember, we're being
Plus,
chill.
Yeah, that would be hard. You could Scantron it. We all have full Scantron somewhere.
Oh, cool.
choice a lot of times. I mean, I use it sometimes,
Yeah,
but especially in the initial phases of learning.
that's true. Yeah.
I learned just living in
Okay, so we just talked about exponential form. Now we're going to talk about log form. We have the same things. We have a base, we have an answer, we have the exponent. They're all there, but they're in different places. So in log form, it is log, the base goes here, base B of the answer goes here, equals the exponent. And the way we read that is log base B of A equals X. So if we did this guy right here, well, so if we took this one and we wrote it, went from exponential form into log form, it would be log, what is the base of that problem? 2. So the 2 would go as a subscript, a little smaller and a little lower of the answer. What's the answer part? 6 equals the exponent. What's the exponent? X. That is log form. A logarithm solves for the exponent. Logarithms solve for the exponent. A logarithm is an exponent. The answer to a logarithm is an exponent. So, when I'm looking at your paper and I give you a line to write your answer, it should look like this. All of that part should be on the line with a subscript. This whole part should be on the line, and the base should be a subscript down below. Do you understand format? Okay, now let's start working some examples. So that's what I have at the bottom of the page. So at the bottom of the page, we're starting our examples. The first one is 2 to the x equals 5. This is another one we don't know. We don't know what power to raise 2 to get 5. So we have to use logs. So in log form, this would be log. What is the base of that problem?
2.
2. So 2 is your subscript. What is the answer part of this problem? 5. Equals, what is the exponent of that problem? X. Okay? Exponential form, log form. All right, let's look at the next one. Let's switch forms. Oh, first of all, is the next one true?
Yes.
It is. Because what does a 1/2 power mean?
It's
Square root. And the square root of 9 is 3. All right, so this would be log. What is the base of that problem? What is the base? 9. 9. What is the answer part of that problem? 3. And it equals the exponent. What is the exponent? 1/2. So this is log form. And we're going to use log form to solve for exponents. So anytime we have a problem that we can't solve, due to an exponential that we can't solve, we're going to have to use logarithms. All right, now, sometimes you're given log form, and it has to go backwards to exponential form. So with this problem, it would read log base 3 of x equals 2. What would that look like in exponential form? So exponential form is base raised to an exponent equals the answer. What is the base? 3. What is the exponent? 2. What is the answer part? Good. All right, the next one. Log base 12 of 12 equals 1. What is the base? 12. What is the exponent? 1. Equals, what is the answer part? 12. Okay? Is that a true statement? Is 12 to the first 12?
Yes.
All right. Questions about switching forms? Okay. So, I have one we just did. I want to point this out. When the base and the answer part are the same, it equals 1, just like the one we did. 12 to the first equals 12. So we had log base 12 of 12 equals 1. Because if the base and the answer part are the same, a base raised to the first power equals itself. Okay? Now this one is interesting, and watch out for this one. Log base b of 1 is always going to equal 0. Because when we raise any non-zero number to the 0 power, what do we get? 1. So any base raised to the 0 is 1. All right, we're going to use what we just learned to evaluate some logs. So we're going to use what we just learned, and we're actually going to combine it with some things we talked about with exponents. So the first one is log base 5 of 25. So a logarithm equals an exponent. So I'm just going to write equals x. x. I'll let x represent my exponent. All right, use switch forms on this problem. Write that down. Everybody in here, write down the exponential form of that logarithmic equation. We would read this problem, log base 5 of 25 equals x. So 5 is your base, x is your exponent, 25 is the answer part. Now, right now, many of you know the answer is, go ahead and say it, 2. That's right, because 5 squared is 25. Okay? Now, I also want to show you this. Could I rewrite 25 as 5 squared? Yeah. And anytime we can rewrite it with equivalent bases, the exponents must be equal. That's going to help us on the problem number 3. Some of them we need a little more help than just looking at and saying it. All right, so this is supposed to be 0.2. Let me throw a 0 in there. It's a little hard to see that. Oh, that didn't really help either. So log base 5 of 2/10. Log base 5 of 2/10. Okay, so if we set this equal to x, and then we switch forms, we get 5 to the x equals 2/10. Well, if I wrote it like I kept saying it, instead of 0.2, if I wrote actually 2/10, do y'all see what 2 over 10 would reduce to?
1 over 5.
1 over 5. So it's really 5 to the x equals 1/5. Because 2/10 is the same as 1/5. Now, every one of you knows the answer to this question. What do I have to do to make it go from this to the reciprocal? -1. -1. So we could write it like this. You don't have to do this step on this one. You don't have to. So x is -1. You could go straight from here to here. All right. The third one is a little trickier. It's a little trickier. But the process is the same. So what we're going to do is we're going to always say the logarithm. A logarithm equals the exponent, so we're going to set it equal to x for an exponent. And we're going to switch forms. So we're going from a logarithm to an exponential. Their inverses, we'll look at them soon as inverse functions. So when we switch, we get 125, that's our base, to the x equals 25. That's our answer part. Now, when you see 25 and 125, do you recognize that both of those are a power of 5?
Yes.
Yeah. 125 is 5 to what power? Yeah. And 25 is 5 to what power?
Squared.
Squared. So, for these two to be equivalent, this exponent must equal that exponent. So 3x must equal 2. So we would divide by 3 and get x equals 2/3. All right, so that is evaluated. Now, I chose to do every example using base 5. It could be any base. It could be base 2, base 3, base 4, base 12, any base. Sure. All right. Okay, so common log is base 10. Natural log is base E. Those two are pretty special. Common log. We'll give you a minute to write and then we'll talk about it. Common log is a log with a base of 10. Our number system is based off base 10. Remember when you were in elementary school, you had to talk about the tens place, the hundreds place, which is just 10 squared, the thousands place, which is 10 to the third. You had to understand your place value based on a number system, which is base 10. So we have a common log, which is very common because that's what our number system is based off of. Natural log, we learned yesterday about the natural base, which is base E, and that yields natural log. So anytime we have a log, base E. Now because these are special, they have special names. Log base 10, we can just write as log. Anytime it does not have a base written there, it is assumed to be base 10. And then base E, instead of written this way, is written natural log. Now, ln stands for natural log. Now, in our language, we put our descriptors first, right? Mm-hmm. So we call it natural log. But the gentleman that created the natural log did not speak English, and so the descriptor comes second. That's why it's ln instead of nl. All right.
Is it log natural?
Yes.
That's so stupid.
Natural. Yeah. All right. So it's just written ln. So we never write log base E. We write ln. We never write log base 10. We just write log. So, if I gave you ln, I tried to combine letters, ln of 4, and ask you to switch that to a different form. So we would say equals x. Alright, so Alex, if we're going to switch forms here, ln is what base? It doesn't say it, but what base is it? E.
E.
Natural log is base E.
Nice.
So it would become e to the x equals 4. So this is exponential, that is log. So if we had this one, it's our common log, there's no base written there. Log of 1,000 equals 3. What is my base? 10. So if we switch forms, it would become 10 to the third equals 1,000. Okay, so we get that? Alright. Now, we're going to evaluate logs. And on your quiz Friday, part of it will be calculator, part of it will be no calculator. So that's how I'm going to break this up. Some no calc, some calc. Alright, after we do these for a little while, some of you guys are going to be able to look at it and just know the answer. And some of us are still going to, every time we're going to have to say equals X, switch forms, then we know the answer. Okay, so some of you can look at this and understand if it's log with no base written, it's base 10. You're going to go up. My base is 10. My answer is 100. I squared it. You're going to go, it's 2. Others of us have to go equals X, switch forms, 10 to the X is 100, and then we'll go, oh yeah, 10 squared. And that's how we'll get our answer. Alright, so number 2, logs of 1,000. So we know a logarithm equals an exponent, and we switch forms. So it's 10 to the x equals 1 over 1,000. Okay, what power do I raise 10 to get 1,000? 3. But because it's a reciprocal, it has to be negative. Good, Dave. So this is -3. Do you guys know from science, you just count your zeros? Yep. Okay, good. All right, natural log of e. So if we had to evaluate this, we set it equal to x, and we switch forms. So natural log is what base? E. So it's e to the x equals e. So what power do we raise e to get e? 1. Natural log of e is 1. Now, these we can't do without a calculator. I don't know what power to raise 10 to get 2.7. I know it's getting smaller, so it's going to be less than 1. But I don't know what it is. So, I have to take my handy dandy calculator. Okay? So everybody pull out your handy dandy calculators. Alright. The log button is right beside the 7. The log button is right beside the 7. So you would just punch log 2.7, enter. So we get this is approximately 0.431. Did you get that?
Do we have to do approximately?
No.
Where's log? Got it.
The log button is right beside the 7. Alright, so what does this mean? This means if I raise 10 to the 0.431, it would be about 2.7. That's what that means.
Where did you get the base?
Okay, if there's no number written, it's assumed to be base 10, because that's the common law. Alright, this one we would just punch in ln of 6. Natural log is right below log, so it's right next to the 4. And we get approximately 1.792. So what does that mean? It means that our number e raised to the 1.792 is approximately 6. That's what it means.
The E's alpha sum. This one.
To do e, you want to do the blue button and ln, that gives you e to a power. If you just need e by itself, the blue button and divide. If you're looking for e. Okay, questions about evaluating? These are our last two. Yeah, I know. Okay, so I'm a big fan of always switching forms. I like to use the inverse. So the inverse of an exponential is a log. The inverse of a log is an exponential. So anytime I get something weird and I don't know what to do with it, I'm switching forms. So on number 1, it really is a base raised to an exponent. Exponent's weird. Exponent's a log. That's different. But it's a base raised to an exponent. That's going to equal an answer.
So it's 10 log.
Okay, so now I have an exponential form, and I have no idea what it means. So I'm going to switch forms. When we're working with exponentials and logs, whenever you hit a wall, you're like, I don't know, switch forms. So if we switch forms here, this becomes log base 10 of a equals the exponent. So the base goes here, the answer part goes here, and the exponent goes here. Weird exponent, it's a weird exponent, but it goes right here. Alright, so do we ever write log base 10? No. Nope, that's a common log. So this is really just log of a equals log of 4.
That's the answer.
So a has to equal 4. The answer is 4. Alright, the second one, I'm going to switch that x to a different variable because it's bothering me. I don't know why I wrote it like that. So this is going to change to a different variable. So Betty, pick something besides x.
Why?
Y.
Z. Z.
Z looks like a 2.
Not if you put a line through it.
Alright, so log base 5 of 25 to the y. So this is a logarithm. The answer to a logarithm is an exponent. So we're going to say it equals x. It equals an exponent. That's where I wanted my x to be. Should have thought about that first. Alright, so now we're going to switch forms. 5 base is 5. What's my exponent? Base raised to the exponent equals the answer.
25.
My exponent is the x. And the answer is 25 to the y. Okay, now last time we were doing these problems, as long as we have the same base, those exponents had to be equal. We don't have the same base right now, but can we make the same base? Yeah. How can I rewrite this as 5 squared? Okay. So x has to equal 2y. The answer is 2y.
Yeah.
Alright, and that is all I have for examples today. We are done learning new material. These notes will be posted to Blackboard, so if you were in and out. Also, I recorded this lesson, and I will try to post it to Blackboard and YouTube.
That's
Okay, it's still recording right now, folks.
They're
And we have 7 minutes. before the bell. So if you're packing up, that's fine as long as you're getting out your Chromie to start your homework.